Okay, so for the formative assessment piece, making sure you know all of the learning targets for 6.1. First thing you have to be able to do is, given an exponential, which looks like this, y equals some base raised to a variable power, xt, whatever they put there. With an exponential, first thing you have to decide, is it growth or decay? So again, if the base is bigger than 1, it's going to be growth. Because as you're raising that to a power bigger than 1 and multiplying it by itself and keep multiplying by that constant multiplier, if it's bigger than 1, it's going to grow. If it's less than 1, it is decay. It's going to be decreasing. So the growth graphs should look like this. It should be growing as you go to the right. And if there isn't a start value here, your start value is always at 0, 1. If it's a decaying graph, it should look like this. It's getting smaller. It still goes through the point 0, 1. Okay, and we talked about domains and ranges. Domain of both of these are always going to be all reals. The range, as long as there's no transformations involved, the range will always be y is greater than 0. So all the y's are greater than 0 in both cases. Domain is all reals. They both go through the point 0, 1. If b is greater than 1, it's a growth. B is less than 1, it's a decay. Okay, so with this one, because it's 5/4, 5/4 is bigger than 1, so it's going to be growth. Then it says to graph it. So to graph it, all I really need are 2 points. 1 point's easy, 0, 1. And let's make sure you know why it's 0, 1. When you put in x is 0, anything to the 0 power is 1, no matter what the base is. So that's why with all of these, no matter what the base is, when you raise it to the 0 power, your answer is 1. You need to come up with one more, so I would probably put in 1. That's the easiest one to put in. So if you take 5/4 and raise it to the first power, so when x is 1, the exponent, when I take 5/4 to the first power, I get 5/4, or 1.25. And that's all you need is 2 points. One's given, one you know will always be true. You just have to plug in one more point, and 1 is usually the easiest. So when you graph it, if you have this listed, you don't really have to show me the points on the graph unless I give you a piece of graph paper to do it. So 0, 1, and then 1 is going to be 1.25. So if I gave you graph paper, I'd want you to try to do it somewhat accurately. But if you have those points listed here, I now don't really need to see that you label them over there. Okay, and it's an increasing graph. It makes sense, it's getting bigger. So that's what you need to do with graphing. All right, then when we get to the word problems, talks about the value of a car. Be careful of this. It says in thousands. So when you see 24, that's 24,000 when you look at it. Down here, if you think of that, that's 6,500. So if it's in thousands, you could say that was 6.5 thousand. So when you go to write the equation or to answer this question, you either have to convert that to 1,000, 24,000, or you have to convert that to 6.5, whichever you feel is easier. All right, so here's the equation. They have to give you that equation. T is the number of years since the car was new. It says identify the annual percent increase or decrease. Now increase is easier to look at, decrease a little bit harder, but just realize all this is whatever the base is, the difference between that number and 1. So if it's smaller than 1, you're just going to take 1 minus 0.83. If it were bigger than 1, if you had a base of, let's say, 1.31 raised to the t, now you just take 1.13 minus 1. So you're either going to take, if it's bigger than 1, take that minus 1, because you don't want to get a negative, or if it's smaller than 1, you're going to take 1 minus that percent. And so when you do that, you get 0.17, but it does ask you to identify the annual percent. So you need to convert 0.17 to percent. So you always just move it 2 places, because this is 17 100ths, and that's what a percent is, how many 100ths you have. So that, to answer that question, when I move it 2 decimal places, I get 17%. So it's decreasing by 17% each year. Okay, so that's how you find the percent increase or decrease. Just take the difference between 1 and that number. You're either going to take 1 minus that number, or you're going to take that number minus 1 to get your percent increase, or in this case, percent decrease. All right, then it says estimate when the car's value is $6,500. So that means the card's value is $6,500. I'm going to change that to 6.5. So because I'm talking about thousands, that's 6.5 thousand. And then I have 24,000, so I leave it as 24, and 0.83 raised to the t or the x. Now again, if you change this to 24,000, then you can leave that as 6,500. All right, to solve these, we said we're going to put this into y1, that into y2. So I go to my calculator, I go to y1, I'm going to put in 6.5, and y2 I'm going to do 24 times 0.83 raised to the x. And again, if you have this as 6,500, just make sure that's 24,000. So then all you have to do is make sure you go to your window. Now I don't know how many years that's going to be. I would say either put 0 to 10, 0 to 20 maybe. It's probably not going to be more than 20 years where the car is going to depreciate down to 6,500. But I'll put 20. And then you have to adjust your y's. So since I'm in thousands, I can say from 0 to 7, because that would be from 0 to 7,000. I have to make sure this number, because that's going to be that straight line across, I have to make sure that number is in my y's. Okay? If you said that was 6,500, then you want to make sure that you go from 0 to 7,000. So depending on how you wrote this equation will depend on how you set up your y's. So I set up my y's in thousands, so I'm going to go from 0 to 7 to get that 6.5 on my picture. Again, if you had 6,500 there, you would have to go from 0 to 7,000. Then I'm going to hit graph. There's the line y equals 6.5. So you should always see, if your window is set correctly, you should see that line going straight across. And here's my exponential that's decreasing. And I want to find out where they intersect. So I go second calc. I go down to intersect, number 5. It says first curve. Yep, that's the equation of my first curve, that straight line. Second curve, there's my exponential, yes. And guess, I'll just arrow up to about where I think they're going to intersect. And it says at 7.01 is when y is 6.5. So my x value or t value is 7.01. So it's, and again, make sure you label that. That would be in years. It says estimate when. So it's after that many years. If you rounded that to 7, that would be okay as well. But make sure you're using your calculator and you're doing second calc intersect. Okay, let's do this one real quick. Population of the city was 1.6 million. So that's 1.6. I'm going to leave it in millions. During the next 15 years, it increased by 7.6. So again, we're going to take 1 plus that percent increase. We have to change it to a percent, so that's 0.0176. Remember, we have to move it 2 places. So that as a decimal is 0.0176 raised to the t power. Okay, so that's my equation. Y equals my start value times 1 plus my increase as a decimal raised to the t power. And now it says estimate the population in 2009. Remember, t is the number of years after 2000. So 2009 is 9 years after that. I'm just going to write that as 1.0176 instead of the plus, but I'm raising that to the 9th power. So then on my calculator, I can just do that in that order. I can take 1.6 parentheses 1 plus 0.0176 raised to the 9th power. And when I do that, I get 1.87. So remember, we have to answer that question. It's 1.87. This is in million. We need to say million people, or just at least make sure you put 1.87 million. Okay, so that's examples 1 through 3. That's what we did on day 1.